Hello my dear students, welcome back to the St. Joseph Composite PU College, Vijaypur. I'm Rahul, chemistry faculty, and in this video I'm going to discuss non-ideal solutions. Okay, before we're going to discuss the non-ideal solutions, let me introduce the definition of non-ideal solutions. This is the definition, students. What we have here: when a solution does not obey Raoult's law, let me highlight the Raoult's law here. Raoult's law, or the entire range of concentration, means it may be from the lower concentration or to higher concentration, the solution do not obey the Raoult's law, and such solution is called as non-ideal solutions. In the previous video I was explaining to you about the Raoult's law. The Raoult's law given as the partial pressure of a solution equals to the partial pressure of the one of the component, say A, multiplied by mole fraction of the component A here. This is the equation produced by the Raoult's. In that, you have to calculate the partial pressure of a solution using the partial pressure of the solvent, or you can say that component at the pure state multiplied by its mole fraction. Now, for a non-ideal solution, this equality not present. This is not equals. Means whatever the pressure is there in the reality, in the laboratory, whatever the pressure you calculated, that is exactly have difference between the calculated value from the Raoult's law. Means theoretical value, or you can say that the predicted value by the Raoult's law and practical values are different. And therefore, there are two possibilities are there. The one possibility is that this P may be greater than predicted value. Predicted by Raoult's law. Predicted by Raoult's law. This is one possibility is there. The other possibility is P may be less than the predicted by Raoult's law. Raoult's law. Okay, there are two possibilities are there now. Now what I will do that, just I will name these. So what is observation here? The pressure is greater than predicted by Raoult's law. Means it is somewhat positive, it is greater. Therefore, this is called as a positive deviation. Positive deviation from Raoult's law. And this one, which is less the pressure as predicted by Raoult's law, therefore it is less than the predicted value of Raoult's law, therefore it is called as negative deviation. Negative deviation. Okay, one thing. So let's understand that why the positive deviation is occurring in a solution. Why the solution do not obeying Raoult's law. Let's understand this taking the examples for the positive deviation. In positive deviation, let me have the solute here. These are solute particles, and again these are the solvent particles. And in between them there is a force of attraction between the solute particles and between even solvent molecule. There is a force of attraction is there. Okay, let me write these are the solutes. It is solute, and this one is solvent. It is a solvent. Okay. Now what is happening here? The interaction is there between when you mix a solute and solvent in a container. There is an interaction is produced between the solute and solvent, and this is the interaction. Okay. In this interaction, you can observe that to show a positive deviation, this interaction should be less. Okay, or you can say that weak interaction between solute and solvent. So this is the base for showing a positive deviation. The interaction between the solute and solvent is there. No, that interaction is very weak as compared to interaction present between the solutes and interaction present between the solvent molecules. But when solute and solvent combined, there should be an interaction between solute and solvent, and that interaction is weak interaction. And because of this reason, the molecules get a tendency to get escape from the solutions. So therefore, you can say that the molecules ready to escape from the solution. Okay, so when the molecules are ready to escape from the solution, it means that they can produce more vapor. Means the molecules can get converted into vapor phase. the more vapor phase is there, or you can say more vaporization, more vaporization, more vaporization. If obvious thing is that more vaporization is there in a container, there is more vapor will be there, and those vapors are colliding with the wall of container and also colliding with the surface of the solution and producing more vapor pressure, and that producing here more vapor pressure, more vapor pressure. Okay, this is one. Let's go and understand with negative deviation. What it contains in the negative deviation? Negative deviation means the pressure which is calculated in the laboratory, it is less as compared to the you can say that the pressure calculated by Raoult's law. Okay, now why it is happening so? Because let me take an example here. This is solute, this is a solute, and this one is solvent, and between those two there is an interaction. Interaction is there between the solute. Let me write it as a solute. This is solute, and this one is solvent. Solvent it is. Okay, and between solute and solvent, when you mix solute and solvent together, there is an interaction is produced. Okay, this is the interaction, and this interaction is strong interaction. This is a strong interaction. Strong interaction. Interaction between solute and solvent. And because of this reason, there is an interaction is there between, more interaction is there between solute and solvent, and because of this reasons what happened, now the molecules are held very strongly, and because of that molecules are not ready to escape from the solutions. Molecules have less tendency, to escape from the solution, Okay, this is one part. If the molecules are escaping less in quantity or less vapor is produced there, by this what happens? The less vapor is produced, less vapor or less vaporization. Okay, vaporization is very less. If the vaporization is less, obviously the vapor molecules which are colliding with the wall of container and exerting a force on the surface of the solution, that also becomes less, and resulting here the less vapor pressure. Okay, so this is how we calculated, or you can say understood the relation between the interaction between the solute and solvent, and that leads to the formation of positive and negative deviations from the Raoult's law. In the next video, I will take a particular examples for the positive deviations, and I will write the molecular structures, how the examples, this whatever the spheres right now I taken. In the next video, I will use particular molecules for a particular deviations. And still that, thank you for watching, students, this video.